Hello! In this video, we are going to make a circuit that uses an Arduino to make a light blink. And I will show you the code, and actually we'll look at it in both block language and text code. So we got to go to circuits, and we're going to create a new circuit. And when it opens, we are going to get a breadboard. And we're going to take an Arduino. We don't need to bring in a battery or any power source because we can get power from the Arduino. Looks like that didn't come in, or I am super lagging. So I may get two. Anyway, we need those two things. We're going to need an LED, and we're going to need a resistor. Okay, and then I'm just going to wait a second and make sure I don't have two of these. It doesn't look like I do. Okay, I'll zoom in a little bit. And by the way, right now I'm dragging my mouse. Sorry, I'm dragging my mouse wheel. So if you need to move to see something, this is called panning, and you can hold down your middle mouse button, which I also call scroll wheel. Okay, so as I mentioned, so Arduinos are made for you to have code that controls a circuit. So it can give output commands to components such as an LED. So it's going to give output commands to say turn on and then turn off and then turn on and then turn off. And it can take input commands from sensors. Anyway, we can start. Well, first let me show you some more things. So all of these pins right here are called digital pins. And one thing I want to point out is this little squiggle here, it's not a minus symbol. So this is not -11 and -10. It's a tilde, and it indicates that this is capable of pulse width modulation. Pulse, actually, anyway. Oh, that won't be concerning us today, but essentially it's for servos and components that need that PWM. Okay, this is where you would plug in sensors. And then you can see there's different power things scattered about the board. There's a ground up here. There's a couple grounds here. There's only one 5V. There's a 3.3V. And this is also a power port. So I'm going to take a ground to here, and I'm going to turn that black. The Arduino doesn't care what color it is, but I always make sure my wire color matches convention to make it easier for learners. So anytime I want to ground something or put it negative, I typically make it a black wire. And similarly, I'm going to take 5 volt to the positive channel and turn that red. Okay, so we haven't powered anything. I mean, so we don't have any components on the board, so that power's not going anywhere yet, but it will go into the LED. So we're going to remember that we want electricity to flow out through the power source. So the electrons are going to throw through the negative into an LED and then back into the power. So, and as you learned in the previous sketch, we need a resistor to slow things down. So I'm going to take a resistor that goes from the negative channel into the negative leg. So if you remember that the negative leg is the shorter leg. And I'm actually going to turn this LED upside down so the shorter leg can be connected here. So notice that my LED is highlighted, and if you don't like red, you can change colors. I'm gonna go blue today. Anyway, this right here will rotate. So I'm going to have it so it goes straight up and down. And then I'm going to place it so the short leg, which is also called the cathode, is in the same column as the resistor. So now I'll have electrons that flow from the negative in through the resistor to slow it down, and then out through the anode. So the long leg's got to go back to positive. So I need to take a wire from long leg to positive, and I'm going to make that red. And I haven't paid attention yet to the value of the resistance. The resistance is currently 1 kilo ohms. I'm going to switch this to regular ohms. So the equivalent would be 1,000 ohms. So if I start simulation, you'll see what happens is this is going to plug into a power source. And okay, so it just turns on because it's getting the power it needs. Notice that it doesn't blink. And it doesn't blink because I still haven't used any command ports. And so when I need to send data to a component, it's got to come from one of these pins. Now, because I already know the secret, I know I'm going to pull it. I could use any of these pins. I'm going to use 13, and you'll see why in a second. So I'm actually going to click a couple places along the way so you can tell, so that I didn't cover anything up. So the only reason I clicked my wire as I made it is because I didn't want to cross over anything. In fact, I'm going to delete it because you can't really see 13. So I'm going to pull this down a little bit. I'm going to click up over the board and bring the wire down this way. Okay, and I'm going to plug it into the long leg, and I'm going to make it blue again. Blue, donde? Okay, so there is my circuit. And actually, you don't need this wire because when you plug into a digital port, it will also use power, but I don't think it hurts anything if we do it. So let me click Start Simulation again. Oh, we do need to remove it. So since the LED is getting constant power, it's not allowing the program to work. There's a program in here. I'll show you it in a minute. So I'm going to delete this red wire. And so now I have a component where it's getting the power from pin 13. So technically you don't need this wire, but I'm going to leave it there because if we added more components, we might need that connected. One more time to start simulation, and now you can see that the LED is blinking. Yay! And I also want you to notice that there's an LED up here blinking. This is called the onboard LED button. Now this LED is connected to pin 13, which is why I chose pin 13, because Arduino circuits, the Arduino has this onboard LED and it's connected to pin 13. So it's typical if you're looking at tutorials that you will see LEDs plugged into pin 13 as a default. They can plug in elsewhere, but you will notice, let me stop simulation. If I click this and move this wire, the program doesn't work anymore because the program currently in the simulator tells pin 13 to blink. So you can see this one's still blinking, but when I move it to 11, 11's not blinking. So I'll stop simulation. I'm going to move this back to 13, and I have it blinking again. Okay, so remember, if you want it to be a little bit brighter, you can turn the resistance down. So if I start simulation, I get a brighter light when I blink. You can even change this when it's blinking. Okay, so let's have a look at the code, because you're going to change the code a little bit before you turn it in. So if we go to code up here, it's going to show you blocks. And it's pretty easy to, I'm actually surprised there's not a loop around this. I'm going to go, and I want you to do this anyway. We're going to go where it says blocks to text. And we're going to continue. Okay, so here's what this is doing. First of all, this line tells the Arduino which pin it's going to use, and it uses pin 13. So remember when I moved the wire over to 11, I would have needed to change this number to 11, okay? But we're going to keep that as is. So this says pin 13 is going to be used and it's an output. If I take this line away, you would get a syntax error. I'm not going to do that. So this basically says digital write 13 high. That means turn on pin 13. And then it says to wait for 1,000 milliseconds, which is equal to 1 second. You don't have to type this stuff in, but what I'm doing is these are called comments, and comments are used so humans can understand the code. The Arduino ignores this stuff. It won't understand these lines. That's why it has these in front of it. Okay, so then it says digital write 13 low. So if high turns it on, it's logical that low would turn it off. So this is turn off in 13. And then it says wait for 1,000 milliseconds. And notice this isn't a loop. So a loop is something that executes over and over and over. When we finish this line, it goes back to this line. Then it does this and this and this goes back to this. So it's going to go on, wait, low, off, wait, on, wait, off, wait. So I'm going to scrunch this in a little bit. I guess it doesn't let me do that. Okay, that's fine. But now you can see the simulation. I haven't changed anything, so it's doing the same thing. Suppose we want to make this blink faster. Then we want a shorter time when we wait. Now watch, if I only change this line, it stays on for half a second, but it stays off for a full second. You can't really tell that. Let me turn this one up. Oops, stop simulation. If I change this to 2000, you can tell that it stays off longer because it turns off, then it waits for a whole 2 seconds, which is why it's typical to have these numbers to be the same value. So I want you to set these both to the same value, and I want it to be less than 1,000. So I'm going to use 300 in both of them. And notice that I just accidentally lost a parenthesis. So you have to be careful when you're changing code, because if you lose something, you're going to get an error. Okay? And that's what gets frustrating if you're not a programmer. So you'd have to reach out to me for help. But if I put the parenthesis back in and run it, it's fine now. So you can see it's blinking pretty fast. Make sure you don't make this number too low, because if it's too low, the processor won't have, like, the board doesn't have enough time to process it, and I won't see the blink. But what I will want you to do is copy your script or snip your script and the code, because I want to see your code. So keep this open, go new snip, and you're going to copy that. So this is what's going to go in your notebook. I hope it goes well. Please reach out if it doesn't. If you get an error in your code, copy your code, paste it in an email, and I'm usually able to spot the problem. So I hope it goes well. Have a lovely day.